I can see on the right here that it is recording. So Neil,
Great.
you can go ahead.
Okay, I will. Here is the agenda for today. I broke my presentation into four parts. Starting with an introduction, I'm going to give you some background on my research interests and what the literature says about some of those research interests, which brought me to the research questions that I answered in my dissertation. Then I'll explain the methods, including the sample data that I collected, the measures that I created out of that sample data, and the analyses that I performed, all to answer my research questions. Of course, we'll talk about the results, so I have some descriptive statistics for you and the results of the regressions that I performed. And then in the discussion section, I'm going to share what this means for practice and for research, just kind of the so what section. The study, of course, also had some limitations that I'll share with you and some ideas for future studies. Let's begin. My research interests come from my scholarly life and from my professional life. My scholarly career started in food science at the University of Minnesota, where I learned about food safety and I learned about food defense. My graduate school interest brought me to learning technologies, where I learned how to use digital technology in teaching and learning. And in my professional life, I lead food safety learning and development at QAI, Quality Agriculture International. That's a pseudonym for the company that I work for. For the purposes of this presentation, we're using that as the pseudonym. So that's what I mean by QAI. My research interests are at the intersection of learning technologies and food and agriculture. So in learning technologies, I'm interested in improving learning experiences that use technology. And in food and agriculture, I'm interested in improving food safety. So, for example, preventing incidents like salmonella or allergens or, all these recalls and things you might hear about from time to time. I have found many bridges at the intersection of these two fields. But specifically today, we're going to focus on three of those. That's transfer of training, instructional design, and program evaluation. So I'm going to next explain what some of the literature says about that and some gaps that I've found. First is transfer, this concept of transfer. So transfer is the use and effectiveness of skills applied into context after training, especially in a workplace. So imagine you're at work and you go online, you complete some training, and then when you return to work, you have to use what you learned, and you want that to have an effect on the whatever it is you're working on. That's called transfer. And transfer is influenced by instructional design, so the way that the learning experience was actually made and designed, individual learner characteristics, and the work environment. For example, does your manager show support or encourage you to use what you learned, and do your peers do the same, and how's the environment, the culture that you're working in to transfer. Measuring effectiveness transfer is about using business results that serve as evidence that transfer occurred. And that's what I'm doing here. There's a couple of different ways to measure transfer, one of which is effectiveness transfer, and that's what I'll be explaining. There's a gap in the literature that I found. Transfer is often measured using a self-reported questionnaire at the end of the course, for example, not direct observation or the results. And that can be a subject of some bias. And it only reaches so far to give us the insights that we need about whether we're actually having the impact that we want with our training. The second idea I want to share with you is instructional design. Instructional design is the process that teachers and educators and, instructional designers, people who work in learning and development in the industry, they use this process to create learning experiences. And it goes like this. You basically start by analyzing the needs of your audience, and then you design a learning experience according to those needs. You develop materials to help you deliver the learning experience according to that design. You implement it, you basically deliver the training, and then you evaluate how effective it was afterwards. And one aspect that I'm particularly interested in about instructional design is knowledge assessment. And in this case, I'm talking about quizzes, completing a quiz at the end of the training. The idea is that knowledge assessment supports the learner's maintenance and rehearsal. It helps them remember what they learned. It helps them test it out for themselves. And the idea is that that knowledge assessment, that rehearsal, would help them transfer the training when they return to work. The gap here is that the effect of instructional design on learning is very well studied, but the effect on transfer is a little bit less so. So you can start seeing how I'm putting a couple of gaps together. You can see how some of these things are connected. I'd like to share with you this framework of program evaluation. Program evaluation is just how we determine if what we're doing is working. It's one way that you can do that for training. And in the training space, there's this model, very common model called the Kirkpatrick model of program evaluation that has 4 levels that you can see here. And each level is in increasing impact that the training has. And it gets a little bit more and more difficult to measure the farther up you go here, but it also becomes more and more coveted. It means more, each respective level. So level 1 is reaction. Did the learners like what you did in the training? Level 2, did they actually learn something? In level 3, did they use what they learned? And then in level 4, did that use result in some impact? The idea here is that we often have a narrow set of measures used in research that typically restricts us to level 1, level 2, most common. Higher levels of Kirkpatrick evaluation are very difficult, and level 4 results are pretty rare. I'd like to give a little bit of feedback on food safety as well. So food safety, of course, is the combined efforts of the food industry and the public sector to prevent and respond to foodborne illness. That's my own personal definition of it. And specifically, I want to discuss food safety management systems. So food safety management systems are what the industry puts in place to keep their products safe. And it follows a cycle a little bit like this. Let's see if I can get a laser pointer here. Yes. It follows the plan, do, check, act cycle, PDCA. If you're familiar with ISO standards, you'll probably be familiar with this. During the planning stage, a food company writes their procedures and their policies, and they may complete some training. They may deliver some training according to those procedures and policies. In the do phase, they're implementing their procedures and policies. They make a plan, and then, okay, they do that in practice at the food manufacturing facilities. During the check phase, we're determining if everything is working according to plan. And one important aspect of the check portion is the food safety audit. And a company will undergo many different types of audits from customers and regulators like the USDA or FDA in the United States, but they also perform internal food safety audits. So they're checking their own systems. At the end of that audit, the auditor who's been trained to do this specifically has a questionnaire. They're going to look around the facility and gather information about how well the manufacturing facility is performing according to the requirements for food safety. And they may have some findings, some non-conformances, places where the facility is not meeting the requirements. So they write those up, and then the facility acts on those, and we have that continuous improvement cycle after that. I want to call out one specific portion here. This is that acronym that we started with, HACCP, Hazard Analysis critical control points, also called HACCP in the industry. And this is sort of a subset of all of the activities that a company would follow. However, it's a very core and important program. This is how you determine what risks need to be controlled. It's your risk assessment methodology, and it's how you will control them. So it's your risk control program as well. Every food manufacturing facility has a HACCP plan, and you can see that there's a series of activities that take part as part of the HACCP plan. So that's specifically what we're talking about for this study. The gap related to food safety literature is that training data is not often connected to the behavior and the results data. So you may have some data that says how many completions you had, again at like kind of level 1 or level 2 if people are learning something, demonstrating that they've learned something from the training. But less frequently will you see some correlations or some data analysis performing at higher levels of the evaluation to show what effect we're having on results specifically. In the context of QAI, at my work there, I discovered something interesting. I was reviewing the training data that we have, and I discovered some variation in the use of knowledge assessments. I noticed that some of our HACCP training courses required a knowledge assessment, and some don't. They're just a PowerPoint slide deck that you have to click through or a video that you have to watch. I also noticed that some learners complete the quizzes and some don't. So that sparked a few questions in my mind. Specifically, is there a relationship between quizzes and food safety results? And does completing a quiz predict food safety audit outcomes? You can see I'm kind of moving towards a research question there. Here's how I'm tying all of these things together. Okay, we've talked about workplace learning and transfer, instructional design, food safety, and program evaluation. I like to think of it a little bit like a jigsaw puzzle, where I'm taking one puzzle piece from each of these fields and creating my study here and the hypothesis for my study. So from workplace learning, I'm using the idea of effectiveness transfer. From instructional design, I'm interested in understanding the effect that knowledge assessment has on that transfer. From the world of food safety, we're using food safety audit results as the outcome variable, sort of the Y variable that I'm studying. And from program evaluation, we're using the 4-level Kirkpatrick model as kind of a framing mechanism for the whole thing. That brings us to my hypothesis. The hypothesis for the study was that the use of knowledge assessment supports effectiveness transfer to reduce food safety audit findings, which are Kirkpatrick Level 4 business results. So here are the research questions. I have 2 of them, and I'll use these tags throughout the presentation. You can see where I'm answering research question 1 and research question 2. So research question 1 is, how does knowledge assessment in HACCP training affect transfer in food manufacturing facilities? And then the follow-up, research question 2, is, does the effect of knowledge assessment persist when accounting for other levels of covariates? What I mean by covariates are other factors. When I include other important factors that might affect your food safety audit outcomes, does the effect of knowledge assessment persist? Here are the methods that I used to answer those questions. First, my sample data. The scope of the data that I collected was from QAI manufacturing facilities in the United States, Mexico, and Canada. And I collected data from the period of January 1, 2018 through September 3rd, 2021, a period of 44 months. I collected training data, specifically HACCP training data, and I collected food safety audit data. There were over 5,500 HACCP training completions, individual training modules completed by folks at QAI during that time. And there were 37 different modules, 37 different courses, different topics, all related to HACCP. 8 of which had quizzes. So only 8 out of the 37 actually included a knowledge assessment at the end of it. That represented 12% of the total completions of all of the training. My data represents 1,175 different learners at 95 manufacturing facilities. And I had 212 internal food safety audit results. One early problem I needed to solve was, how do I determine how much training counts for each audit? Because the facilities have an internal audit about every year. So should I count all of the training that's happened in the past for today's audit, or should I make some decision about how much actually counts? And considering the annual cycle of the manufacturing facilities and just the need to make some kind of decision about that, I decided that training completed since the previous audit counts towards the current audit. So that's the first measure that I started to put together. Let me go into a little bit more detail about those. My unit of analysis, which is how I define one data point. What does one row in my data set look like? How do I define that? My unit of analysis was one audit event at one manufacturing facility. And the outcome data associated with that was the count of internal food safety audit findings at that facility for that audit. And I took the full count of audit findings. That included minor and major findings. For this study, I just included them all as a simple count of all of those findings. The key predictor that I was studying is the count of quiz questions completed during training per full-time employee, per FTE. Employee at the facility. As you can understand, each facility has a different number of people. They vary in size. You know, they could be 20 people at a smaller facility or 2,000 people at some of the larger facilities. So it didn't make sense to compare just raw numbers, because at the larger facility, of course, you would expect to have much more training completed. So this is, you know, sort of a per capita measure. Here are the other factors that I studied as well. These are my covariates. These are those other things that I included that might have an effect as well. So we're looking at the training count per FTE, so just the number of trainings that were completed there. The duration per FTE, how much time did each person spend on the training. The number of unique learners per FTE. This is basically the proportion of the facility's workforce that completed the training. So did you have just 1 or 2 specialized people who took lots and lots of training, or did you have, you know, a larger, broader audience? Everybody took a little bit of training. The average time lag is a measure of how recent the training was completed, and the idea is, do you get better results if it's fresher in your mind, or do you need a little bit of time to implement what you learned? So that's what that helps us determine. And then just simply the size of the facility. So this is, you know, full-time equivalent employees, and the date, just the relative audit date, which is the number of days since the first audit at that facility within my time frame. Just because you might just improve gradually over time, just because as a matter of time. Here are the analyses I performed. So a quick reminder on the research questions. How does knowledge assessment and HACCP training affect transfer in food manufacturing facilities? And does the effect of knowledge assessment persist when accounting for levels of other covariates? So for research question 1, I used simple correlation for starters. The correlation just shows how audit findings vary together with quiz questions per FTE. And I also used regression. And the idea of regression is to write an equation, or have a computer write an equation for you, that predicts the count of audit findings based on the count of quiz questions completed per FTE. And for research question 2, more specifically, I performed multiple regression, which allows you to include multiple X variables to predict the same Y variable. So I included levels of those other covariates as well. It seemed simple enough until I started performing the analysis myself, and I encountered a couple of problems. Thankfully, there are solutions to those problems. So the first problem in the analysis that I faced was that the audit data, the outcome data, is count type data. Right? It's just the count of audit findings that were completed at that facility. Those are usually not normally distributed, but like your typical bell curve distribution from statistics. Instead, they are Poisson distributed, which looks a little bit like figure 3 there. So the problem is that a linear regression wouldn't match the shape of the outcome. So easy solution to that, you just perform Poisson regression instead of linear regression. But then the second problem was that audits are repeated measurements over time at the same facility. You remember I had 212 audit events at 95 facilities. So they had anywhere from 1 to 3 audits within that 44-month period. And linear regression assumes that each outcome is independent from each other. However, in this case, if you have the same facility for 3 audits, it undergoes an audit in year 1, in year 2, and year 3. You often look back at previous audit results to inform the current audit, and so it doesn't make sense that those would be independent. Thankfully, there's something that we can do about that. You can use multi-level regression, which allows the model parameters to vary by facility, for example. So that's what I did here with the intercept. I'll explain that a little bit more in a second. So I used multi-level Poisson regression as my analysis method. Then comes the question, how do we know which variables are important? How do we decide how to do that? Well, I followed a model building and model selection procedure that works a little bit like a tournament. I built candidate models from different combinations of predictors using theory. What kind of have similar predictors were put together, and I made multiple models. Each one of those is just a regression equation. And I compared the model performance. I compared the model performance according to HACCP, that's the corrected Akaike information criterion, which basically measures how well the model predicts the outcome. And then I pitted them against each other, and we're looking for the model that has the lowest HACCP. I did a few qualifying rounds, and then the best model from each of those qualifying rounds advanced to the final round. And that final round was a big battle royale style comparison. And at the end of that, I selected the best performing model of all of those that could answer my research question. Let me give you a little bit more details on that tournament and the results of that tournament. Model 0 is an intercept only, a y-intercept only. It does not include any of the predictors. So it's kind of our baseline to determine if there is some kind of effect of one of our predictors, especially the key predictor. Model 1 includes the key predictor of quiz questions per FTE. And here you can see, I'm spoiling it a little bit before we get into the results section, but here you can see that the HACCP for Model 1 is better than Model 0. Okay, it performs better than Model 0, than just the intercept-only model by a little bit. I also want to point out Model 11. That's the one that ultimately won the tournament. And the predictors that were included in that are quiz questions per FTE. That's our key predictor to answer our research questions. The training count per FTE, the average time lag, that's that recency measure, and the relative audit date. So just over time, time was an important factor. Okay, you can notice the HACCP for that one, much lower than both of those. So Model 11 performs a lot better than the other models. Let's get on to the results. Starting with correlation, just simple Pearson correlation. Was there a correlation between quiz questions and audit findings? Well, no. Quiz questions per FTE was not correlated with food safety audit findings. You can see the number there. The correlation was negative 0.08. That's a very small number. Correlation ranges from -1 to +1, and the closer you are to 0, the less correlated it is. And that was not statistically significantly different than 0 in terms of correlation. So, okay, there was not a correlation between my key predictor and my outcome. Some of the covariates did have important, significant correlations, though. So more training per FTE was correlated with fewer audit findings, as you would expect. Okay, more training, fewer audit findings, good. That's sort of a weak correlation, okay, but there's something there. The higher proportion of employees trained was correlated with fewer audit findings. Okay, good, also what we would expect. And then the larger facility was also correlated with more audit findings, just the more people that you had there, which is also what you could expect. There's more to see during the audit process. Okay, so that's one angle at the picture, but what does regression tell us? This is a table of the results of Model 1. That's the regression model that was just the y-intercept plus my key predictor. So when considered alone, quiz questions per FTE was associated with a decrease in audit findings, as expected. Okay, that's good to know. And in fact, it was about a 59% decrease in audit findings for each unit increase in quiz questions per FTE. So that would mean everybody at the facility completed one more quiz, and each time they do that, another 59% decrease in the number of audit findings. Okay, that's good. All right, we're starting to see the relationship that we're expecting. And remember that this model performed a little bit better than the intercept-only model. But how about research question 2? When I included the other covariates, those other factors that might have an effect, the relationship reversed. So you can see that quiz questions per FTE was actually associated with about a 20% increase in audit findings for each additional quiz question per FTE, which is puzzling. I've come to learn that that's what can sometimes be called a suppression effect. When you include other predictors, you might see a change in the direction of some of your predictors, and that's what happened here. You can see the coefficient, the slope coefficients for these other covariates, and sort of how to interpret those. First and foremost, I want to point out training count per FTE, which had a very strong relationship with the number of audit findings. 99.8% decrease in audit findings for each additional training per FTE. Average time lag saw a 10% decrease in audit findings for each one standard deviation. That's a 135-day increase in average time lag. So the question of recency, this says that the more time that we gave people from the date of the training to the date of the audit, they were able to implement the training better, which is to be expected, right? It's a complicated program. It's a complicated system where you have to pull together a multidisciplinary team and make changes together. And then just over time, we saw about a 5% decrease in audit findings every 285 days, one standard deviation for an increase in relative audit date. Let me show you a visual of this in 2 dimensions. Now, the actual model itself takes place in many dimensions. I don't know, 4 or 5 dimensions, but here's the 2 dimensions that I'm most interested in. The count of audit findings and the quiz questions per FTE. Each one of those little dots on there is the count of audit findings from one audit event. And you can see that line, that's the predicted line of Model 11, the best performing model. And it's not really following the data from this angle. And you can see that the upward slope is not really what you would anticipate either. Yeah, okay, that's very interesting. That's because of the other covariates that are happening, that are included in the model too. So when we only look at it from these 2 dimensions, it seems a little bit like that line doesn't fit so well. Let's get into what this means. What are my conclusions and what should we do with them? For research question 1, how does knowledge assessment and HACCP training affect transfer in food manufacturing facilities? Well, quiz questions per FTE was not correlated with audit findings. And when considered alone in a multi-level model, each unit increase in quiz questions per FTE was associated with about a 59% decrease in audit findings on average. So I conclude that there is a relationship between quiz questions and transfer, just not a very strong one. So the correlation was not there, but Model 1 performed better than Model 0, and we saw that relationship. The single predictor model does not perform as well as the multiple predictor models, however, so let's get to that. Research question 2, does the effective knowledge assessment persist when accounting for levels of other covariates? The relationship between quiz questions and audit findings persisted when 1 or 2 other covariates were included, but not when I included all 3. That's the suppression effect that I mentioned before. In the best performing model, that's model 11, a 1-unit increase in quiz questions per FTE was associated with a 20% increase in audit findings on average. So I conclude that the relationship between quiz questions and transfer does not persist when accounting for other important covariates, especially training count per FTE. That's the one that really changed the effect that we saw. So what does this mean? How do we use it? What am I going to do with these findings? Some implications for practice. I have 3 of them. First is to understand that demonstrated competence, namely through quizzes, doesn't necessarily result in transfer of learning. So my recommendation there is, it doesn't mean that you should stop using knowledge assessment, you should stop using quizzes in your teaching and learning. Like, no, you absolutely should still use those. It's a very important process still. However, what I recommend is, whenever possible, use knowledge assessments that are realistic practices of the actual responsibilities that the person will have to use when they return to work. That will help them recognize situations when they should transfer what they learned, when they should apply what they learned. In this case, the data was about multiple choice questions, just basic quiz questions that were pretty much knowledge checks. Did you learn something from this? And not too much more sophisticated than that. In the case of QAI, where I work, we have implemented practice exercises that simulate actual HACCP plan building. So we've taken this lesson here to basically do that you can do a practice exercise ahead of time during your training instead of only a knowledge check. The second thing is easier said than done, but it's increase the amount of training per employee. Yeah, fine. Of course, that makes sense. Everybody wants to say that we need more training. However, time is a very important factor, especially in food manufacturing industry. So my recommendation here is actually to design role-specific training programs that will help you reach more audiences and give them just enough of what they need. You might need 1 or 2 HACCP specialists that need multiple hours and lots of in-depth understanding of HACCP, but then there's also the HACCP team around them. They may not need to know quite as much, so you don't need to put them through the multiple hours of training, but they do need something. So design role-specific programs that are right-sized for what additional audiences need. For example, at QAI, we've done just that. We've created HACCP team member training, and we've increased efforts to assign HACCP training specifically to target audiences, target learners. The third conclusion is to use business key performance indicators to evaluate your training. You can avoid this limitation of a survey-only evaluation, right? The research has found that those are subject to some bias, understandably. The trainer at the end of the course says, what did you think about this? Are you going to use it? Did you learn something? And there's an incentive to have people respond positively to that, of course. All right, well, there are business results that are happening independently of the training. That's the correlation that I believe we should make. It's difficult, of course. It may not be possible in all situations to show that there's causation, that your training caused these business results to improve, but correlation is still actionable. If you show that this is associated with that, okay, you can do something about that. So correlate training to audit results, non-conformances, customer complaints, recalls, and withdrawals. My study had some limitations, of course. First is that the literature shows that social support and the workplace culture has an important effect on transfer of learning. And I didn't include any data on that. I didn't collect any data on the social support in the workplace. So that has been shown to be important, but just wasn't part of my focus for this study. It may be that different types of knowledge assessments have different effects. So as I mentioned, the training that I studied just had simple quiz questions, just correct or incorrect, true or false, multiple choice kinds of questions. And different knowledge assessments where you might have to simulate what you are going to practice may have a different effect. And more data is needed to elucidate facility-level effects of the predictors. So in the models that I fitted, I was only able to allow the intercept to vary by facility. That's the nested structure of the multi-level regression that I performed. I didn't have enough data to be able to determine if the effective quiz questions varied by facility, for example. So you'd need a little bit more data to do that, maybe a lot more data to do that, namely like a longer timeline could help do that. However, each of these limitations can be turned toward an opportunity for the future. So some future studies. I have some questions for scholars who want to dive into this space, or even maybe some future studies of my own. How do learner characteristics and the work environment affect transfer? In the food safety world, that would be particularly interesting. There's a little bit of a gap in the literature there. How do some types of knowledge assessments differ? Do they make a different effect than others? How about those level 2 facility or even multi-facility effects? These facilities all belong as part of a business as well, and so there might be some effects at the level 3, effect. So you could investigate that a little bit more. I mentioned that I used effectiveness transfer measures. There are also use measures of transfer, namely observation, direct observation of people on the job. So do use transfer outcomes have a different relationship? And there are other effectiveness measures that would be valuable to understand as well. So is there a relationship? What's the relationship with non-conformances, customer complaints, recalls, withdrawals in the world of food safety? Those, of course, are all very important key performance indicators. That brings me to the end of my presentation. So I want to thank you all for joining. And I want to leave you with this. I believe that instructional design matters. We can see the difference that it makes. We can feel the difference that it makes. So to all the educators and instructional designers and teachers out there, invest in pedagogical quality of your learning experiences, and you will see the benefits. Thank you very much.